Hey, we are back with you again on a suggested video for S1 challenge. Hope this too helps. Anomalous secondary growth in Boerhaavia. In plants, the growth in length of the stem and its branches, primary growth. The increase in diameter of axis. As a result of the activities of lateral meristem. Secondary growth. Monocots and some herbaceous dicots possess only primary growth. Gymnosperms and woody dicots also possess secondary growth along with primary. Secondary thickening in dicot stems. The fascicular cambium, inter and intra, which lies in between xylem and phloem, in each vascular bundle is responsible for the secondary growth in stele and is known as intrastellar secondary growth. Followed by intrastellar growth, there will be the formation of a new secondary tissue in the cortex, periderm, by activity of another cambium called cork cambium or phellogen, and as the extra stellar secondary growth. Note monocot stems and roots generally do not undergo secondary growth due to absence of cambium. Anomalous secondary growth. In most dicotyledonous stems during secondary growth, intrafascicular cambium joins with interfascicular cambium to form ring which produces secondary phloem outside and secondary xylem inside. The deviation from the normal pattern of secondary growth th can be termed as anomalous secondary growth. Reasons for anomality: abnormal behavior or abnormal position of cambium. Anomalous secondary thickening in Boerhaavia. Boerhaavia diffusa, italics, a member of family Nyctogenaceae of dicotyledonous plants. Primary structure: epidermis with numerous trichomes, cortex with rhaphides, endodermis, pericycle and vascular bundles are present. Primary vascular bundles conjoint, collateral and open with endarch xylem, and arranged in 3 concentric rings. Inner ring 2 large bundles. Middle ring with 6 to 14 medium bundles. Outer ring 15 to 0 small normal bundles. Steps. A. During secondary growth, the inner, central and middle ring of vascular bundles increase its size to a limited extent by activity of fascicular, intra-fascicular cambium in each bundle. Note interfascicular cambium never develops in these vascular bundles. B. In outer region where most of the secondary growth is confined, interfascicular cambium forms and it joins with intrafascicular to form a connected cambial ring. C. This is the cambial ring which behaves abnormally, produces secondary xylem vessels towards inner side and secondary phloem to the outside in the fascicular region. D. The interfascicular region of the ring produces thick-walled parenchyma cells to inner side and thin-walled parenchyma cells to outer side. Note the thick-walled parenchyma produced between the secondary xylem vessels becomes the conjunctive tissue. E. After a short period the cambial ring ceases its activity. F. Another new cambial ring forms external to secondary phloem called as accessory cambium. Note both parenchyma cells and pericycle helps in the formation of the new ring. G. Accessory cambium behaves normally, produces secondary xylem towards inside and secondary phloem to outside. H. Conjunctive tissue is formed in between them, thus ring of collateral bundles separated by conjunctive tissue forms. I. After short period this cambial ring 2 ceases functioning and another cambial ring arises outside and behaves in same manner. J. Like vice. Finally 4 to 5 successive rings are formed and in the last ring the parenchyma lying in between phloem patches becomes lignified. K. Pressure is exerted in the cortex region due to this stellar growth. L. To face this pressure in hypodermal region a layer of cells develop in the phellogen or cork cambium which produces the cork or phellum to outside and phelloderm or secondary cortex inside that constitutes the periderm. Here you can see the diagram of Boerhaavia showing the 3 rings of versus bundles. Thank you all for watching. Please like, share, comment and subscribe us for more videos. For more videos of your choice just comment us. The videos of your suggestions will be updated soon.